remember, when we do the fast pointer, we're going to skip one. So the fast is going to be whatever the fast is. So let's do Leetcode 141, linked list cycle. So we're given this linked list, for example, this one here, and it has a cycle. What does it mean to have a cycle? That means one of the nodes, the next pointer, will point to a node that we already had before, previously. Like, for example, this last node here, instead of pointing to null, as it usually is for linked list, what's happening is it's pointing to a node kind of in the middle of the list. And that means when you traverse it with current equals current.next, when we reach the end, it's going back to the second element, and it's going to keep doing that forever in an infinite loop. So we have to detect whether there is such a thing, such a, a loop, a cycle. To do that, we can employ the technique called the slow versus fast pointer. So we're going to have a pointer that's going to point to the first, and that's going to be the slow. It's going to be the usual one. When we do current equals current.next, it's going to go there, it's going to go there, it's going to go there, and so on. Then we're going to have another one. It's called the fast pointer. So we start in the same place, but instead of doing one step, you're going to do two steps. So it goes, jumps, and skips the one in between. And then after the next one, it goes one next and another next. It's going to end up, it's not here, right? Because it's just one step. So it's going to end up in the next of that guy, which is going to end up here. So it's not going backward, okay? It's going forward. But because this next is going back, that's why it ends up there, okay? And then, as you can see, there will be a point where the slow depicted in red matches the one depicted in green. And that's how we find out if there is a cycle. If we have the same node reference for one pointer and the other one. Okay. So let's do that in code. I'm going to do Java, like I said before. So let's first initialize the pointers. Here we're dealing with a type called list node. So that's going to be list node. Let's call it slow. Initialize that to the head. And you're going to do the same thing, call it fast. Initialize to the head. They both start in the same place, right? For those who just came late, I'm going to paste the question again to the Zoom chat. Okay, so we got that. So we're going to go. Remember, we're going to go through the list, traverse it using the slow and the fast, and we have to find out if there has a cycle. If the slow matches the same reference or points to the same address in memory as the fast one. So we're going to do a while loop here, and then we're going to go through it. And if we find out that if the fast has the same reference as the slow, that means, okay, we have found a cycle. It returns true. And then we're going to go through the loop. Now, if you go through the loop and you never reach this condition, right, you don't find them to be equal, that means there's no cycle and you have finished the loop, right? So that means you have to return false, meaning no cycle. Okay, so those are the two returns. Okay, now let's fill in the blanks, right? Okay, so remember, when we do the fast pointer, we're going to skip one. So the fast is going to be whatever the fast is, dot next, and then you skip that next, right? You say dot next again. Now, to be able to do this, what must be the condition? This guy here must not be no, right? Because if it's no, this is going to fail, right? And also this guy here cannot be no. If it's no, fast dot next and be no, it's going to fail. It's going to give an exception here, right? So that's why we got to do the loop as long as fast is not null. And the fast dot next is not null. Then we'll keep going, right? The fast is going to be skipping one, and so on, right? So, okay, now what about the slow pointer? The slow pointer is the usual one that you know when you traverse a linked list. So that one, after you do that, check the condition, you could just make the slow be the slow dot next. The same way you do the current equals current.next when we do usual linked list traversal that has no cycle, right? So that's pretty much it. All you got to do is find out if the fast pointer matches the same reference as the slow as it keeps going, right? The fast pointer always traverses two steps. That is, it skips one node in between. The slow pointer is just one node at a time, one step at a time. If there is a cycle, the pointers will come together at some point. And there you go. We got the cases there. Let's submit. Let's talk about time complexity. We are iterating over the nodes, right? If it's no cycle, that means we gotta do like all n, right? Until the thing is no. Even though we use fast, you could technically say, oh, it's gonna be half the time because it's skipping too, but it's still event. Space, I'm not using anything other than these references to the pointer, pointer to the node. So it's constant, all of one. Hey, thank you for watching. If you like this content, please consider making a donation so I can keep doing this for you. I'd really appreciate that if you could donate. All right, thank you so much, and I'll see you in the next one.